There's a new large language model that is causing quite the stir among Silicon Valley insiders and AI technology companies. I'm, of course, talking about DeepSeek. DeepSeek R1 and DeepSeek V3. Some very, very powerful and impressive large language models. But I think there's a lot of nuances to this, not only in the geopolitics realm among venture capital and AI companies, but also just for you and me building AI technologies today. I think that it's worth the deep dive. So DeepSeek, much like OpenAI, is primarily a research company where they are building large language models and trying to innovate on the approaches to build more and more powerful foundation models like GPT-4 or Sonnet or Llama that Meta has. And recently they unveiled DeepSeek V3, which is incredibly impressive. If you just look at this benchmark here, all these benchmarks compared to their previous DeepSeek, to Qwen, Llama 3.1, Claude 3.5, GPT-4o, it beats, if not meets, these other foundational models quite impressively. And they did all of this while open sourcing a bunch of it. So it's more or less open source for you or I to go and use the models and the weights. You can run it on Ollama. It's very impressive. The first thing that I noticed about this model is that it's actually quite big. It's 671 billion parameters with 37 billion parameters being activated for each token. So more or less each word or, understanding of a word in those tokenizations is activating a huge part of that neural network, of that graph within the large language model. Next thing I noticed is that it's a mixture of experts type of model. So it has a few underlying experts within its architecture that it can kind of reference or use within its graph as it's doing inference, as it's generating text. If you're curious to learn more about mixture of experts, I definitely recommend this post from Hugging Face about what mixture of experts is, how it works, the actual architecture under the hood. That's a video for another time, but definitely reference this. I'll put a link down in the description. DeepSeek also published a paper for V3 describing how they built it, the architecture, the cost to training ratio, which is very interesting, but definitely worth a read. The other thing that really stood out to me when reading this paper is the fact that they used H800 GPUs with 2.788 million GPU hours on those H800s, which is absolutely insane. So for those H800s with those number of GPU hours, we could see the cost breakdown in USD for pre-training was about $5.5-ish million, another little bit for extending that context post-training for a total of just about $5.5 million to train the entire foundation model. This all comes at a time when American tech companies, OpenAI, Microsoft, SoftBank, all of these tech companies are preparing to spend $500 billion to build bigger, better, stronger data centers to train new foundational models that they believe will be more and more powerful, requiring more and more compute. Again, all that, they're claiming about $2 per GPU hour and a total of just under $6 million, which is a tiny drop in the bucket compared to $500 billion. DeepSeek followed that up with the R1 model, which I think is really the cherry on the top of this whole story, where R1 is their reasoning model, much like GPT-01, where it can kind of have this iterative thought process before it actually generates the final text that it gives you. R1 is very impressive and again, beats most metrics compared to O1 Mini, DeepSeek V3. R1 is incredibly impressive in this regard. Again, they followed this up with another paper describing how R1 works, the architecture, all this stuff. I think was a really interesting read, but what they did is they actually used reinforcement learning for R1 based on V3. A few things that I want to call out from this paper that I think really captures it in its entirety. First, this graph where we see they have DeepSeek R1 0, which is kind of the iterative approach within the reinforcement learning that they're doing, where they take, they say they take 16 responses and they calculate the overall average accuracy and ensure a stable evolution as they are continuing to apply reinforcement learning. So it starts way down here against a bunch of these benchmarks like Math 500, Live Code Bench, Codeforces, a bunch of well-used benchmarks within the industry. So it starts down here, accuracy is terrible, and it climbs and climbs, kind of logarithmically, it seems, almost levels out. But eventually we see that in many of these regards, it surpasses O1 in its capabilities. I also found this very fascinating from the research. They found that the average response length of DeepSeek R1 on the training set during the reinforcement learning process, it naturally learns to solve reasoning tasks with more thinking time. So as they continue to apply reinforcement learning, it learns to actually think longer and have deeper think sessions, I guess, for contexts and answers that it's going to give. Let's now shift our focus to evaluating R1 in real practice, not only on the DeepSeek platform, but also locally via Ollama. It's an open source model. The weights are out there on Hugging Face. You can go get it, which makes it very interesting for local only development. So we can do Ollama run DeepSeek R1, and we want the 7 billion parameter model, which is the smallest one that they offer, and it boots it right up in Ollama. We can ask it all different kinds of questions, like write a function in Go that, and let's give it something relatively difficult, like maybe JSON unmarginally, that inspects JSON tags on a struct and creates a JSON, an output JSON string. So a simple enough query. We can see that it enters initially its think loop, and this is really the reasoning part of it. So we can see that it needs to write a Go function. I should understand the output is weight, maybe the struct represents this or this, and we could see that it kind of goes back and forth. You've seen this with O1 or Qwen or any of these other kind of reasoning models where they're gonna think first, quote unquote think. But they're going to evaluate different approaches and then give you, in theory, a better answer based on things that it's attempting to think through. So it finished. It took probably about 10 minutes to think, actually. Again, this is like the smaller 7 billion parameter one running on a MacBook. So it went through a lot of different approaches. If I scroll up, it thought about nested structs in Go and unmarshalling things that may look like structs within structs or arrays within structs. Asking this thing to unmarshal JSON correctly into a string from Go structs is no light matter, but I think it did a pretty good job. So let me go up and find the end of the think block right there. And that's basically it saying, okay, I've thought for 10 minutes or whatever. Here's the actual approach. We're going to do this. Here's the Go code, blah, 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 explanation. And it did a thing. Now, using the DeepSeek platform, which today is free and seems that they've been scaling despite all these users using this thing, we can go here, paste this in here. This is that same question. We can turn on DeepThink for the R1 approach to the model and see how it does. So it looks like there it finished its thinking block. If we scroll way up, we can see it's trying a bunch of different things with reflect and seeing, empty tags and other different things that it's concerned about in its thinking process. It thought for about 2 minutes on that one with a pretty long answer, and then gave us an initial approach with using reflection. Now, just because I'm curious, I want to see how Claude can do, and even though I'm paying for the professional plan, we are defaulting to worse responses because we're experiencing high demand. Okay, well, that's fine. Let's see how this can handle that same question. It seems that it came to a similar conclusion using the reflect package, but maybe didn't hit some of the edge cases. So also not a bad response. So this is all great, right? I mean, DeepSeek is got some open source models that are out there freely to use right now. And the platform itself, this platform is free right now. I didn't have to sign up for any of this. It's got awesome capabilities. The web interface works well enough. I mean, what could the problem possibly be? Now, I think it's important to remember, and this goes for any of these AI research companies, is that any of the data that you're sending them is probably going to be part of future training sets. This goes for Anthropic, this goes for OpenAI, and this goes for DeepSeek. And the reason that is maybe important to you or your org, depending on your personal preferences, depending on how secure the data you need to be sending them is that they are a Chinese company. They are a Chinese company, which means that the Chinese government has a hand, or a very heavy hand potentially, in the development and I guess governance of this company and their data. Now, I don't want to comment too much on this because this is definitely not a political channel at all, but it does have real security implications. Sending your raw data, sending raw information via this platform or their ridiculously cheap API right now could present a security risk, depending on your personal security posture or your company's security posture. So please keep that in mind. And I think that this take from Alexander Wang, who is the CEO of Scale AI here in the United States, I think actually has a really good take on this from the sort of competition perspective of what's happening right now with AI companies. Because again, this is not only just your personal security posture, your company's security posture. This does have real world political implications, geopolitical implications. Let's see what he has to say.
So yeah, first of all, the AI race and the AI war between US and China, I think, is one of the most important issues of today. We took out a full-page ad on the Washington Post on Tuesday saying that, America must win the AI war. And so this sort of relative race in AI between the US and China is critical. Today, we released Humanity's Last Exam, which is a new evaluation or benchmark of AI models that we produced by getting, math, physics, biology, chemistry professors to provide the hardest questions they could possibly imagine that are relevant to their recent research to really put the test to the models. To give you a sense, no model is getting above 10% on this test. That being said, what we found is that DeepSeek, which is the leading Chinese AI lab, their model is actually the top performing, or roughly on par with the best American models, which are
that point is definitely worth repeating. Scale AI, which is essentially a labeling and data aggregate company for AI companies, has released a new benchmark based on PhD work and some of the most difficult problems in the world right now. He's saying that DeepSeek's models has some of the best performance on these, which is, again, crazy.
I think we have been all under the impression that the U.S. was way ahead of China as it relates to AI, in large part because we have access to, NVIDIA GPUs and chips and other things that supposedly the Chinese do not have.
For those unaware, what he's referencing is that over the last 4-ish or so years, there's been a chip embargo in China. So Chinese tech companies, Chinese AI companies cannot get the most powerful chips, primarily NVIDIA H100s. That's specifically why they call out in the V3 research paper the H100s and how cheap it was to actually build this foundation model on H800s. What is an H800? Well, it's basically an H100, but severely neutered, and the different cores inside of this enterprise-grade server essentially can't communicate as fast. You can't get as good of clustering to train models as efficiently and as quickly as you would with a bunch of H100s. It's no different than you got a 3080 versus a 5080. The 5080 is just going to be able to be better, chug out better graphics, do better inference, et cetera, et cetera.
I keep hearing from people all week, from people, Chinese AI executives, that they say, we're so close. And by the way, we're doing it with one hand tied behind our back. Our algos are better. We're actually going to figure out how to do this, do it better than the U.S. and in even a more energy efficient way because we don't need these super powerful chips. Are they happen to be right?
There's two things happening. First, it is true. It has been true for a long time that the United States has been ahead. And that's been true for, maybe the past decade. That being said, the very recent event on Christmas Day, about a month ago, DeepSeek released a model, which, by the way, I think is symbolic that the Chinese lab releases, an earth-shattering model on Christmas Day when, the rest of us are sort of celebrating the holiday.
Note that is very intentional. There's no reason that you would release a product or a piece of software on Christmas Day when most of the world is not going to be at their computers at work to start looking at it and taking advantage of it. It's intentional in that they wanted to send that message. I do think that Alexander Wang is correct in that. Because again, if you've ever worked at a startup or within a product org, you want that initial splash in the market to give you immediate feedback, to get immediate users, to start iterating so that you can continue to make that thing better. It can be a little different with these research AI orgs where, essentially they're publishing papers, building models that may build other products on top of it. But again, like, they released a product, they released a platform. So they would want people to start using it immediately, to start getting that iterative feedback, to start getting some of that market share away from Anthropic and OpenAI. But releasing it on Christmas Day, I think, sends a huge message.
And they released it to much fanfare, and then they followed up with their reasoning model, DeepSeek R1, which is the one that we evaluated as top of the leaderboard. The reality is yes and no. So the Chinese labs, they have more H100s than people think.
And these are the highest powered NVIDIA chips that they were not supposed to have.
Yeah.
This is very important to understand. There is a chip war going on between the US and China. There's essentially an arms race to see who can build the best and biggest foundation models, who can really race to the bottom first to build essentially a superintelligence, to be the one to capture that market first, which essentially means that for the last few years, there's been a sort of black market for these cutting edge AI chips from NVIDIA, from whomever, to build the biggest and best foundation models. This part of this investigation from the New York Times kind of blows my mind. The Times spoke with representatives of 11 companies in China that said they sold or transported banned NVIDIA chips and found dozens more businesses offering them online. Several vendors in a vast maze-like market in Shenzhen reported deals involving hundreds or thousands of chips, including a $103 million transaction that would be much larger than any previously reported in China. So back to the paper, this begs the question for me of, is this real? Or are they sort of flubbing some of the numbers, saying that they built this thing super efficiently when maybe they've spent the last few years on a giant cluster of H100s, chugging this thing out just to kind of scratch away a little market share from OpenAI and Anthropic.
My understanding is that DeepSeek has about 50,000 H100s, which they can't talk about, obviously, because it is against the export controls that the United States has put in place. And I think it is true that, I think they have more chips than other people expect, but also on a go-forward basis, they are going to be limited by the chip controls and the export controls that we have in place.
So he and his company, after evaluating R1, estimate that, yes, they do have a giant cluster of H100s somewhere sitting around that they obviously can't disclose because that would be a huge boo-boo on somebody within, NVIDIA, the US government, or wherever, how they got these chips. So they basically, I think, maybe, have probably been flubbing these numbers, and is also probably why and how they've been scaling this platform so efficiently despite so many new users coming on board in the last month. Despite all of that, this has Silicon Valley insiders very concerned that, given whatever cluster of GPUs or something they have, that this team at DeepSeek was able to eat away so much performance from Llama, from Claude, from the GPT model families. This was a fascinating post from the R local Llama subreddit, which is a screenshot from Blind, which is a sort of internal company posting social media thing, where somebody said that Meta Gen AI org in panic mode. It started with DeepSeek V3, which rendered the Llama 4 already behind in benchmarks, which is speculative because Llama 4 is not out, but maybe internally there's some reports. Adding insult to injury with the unknown Chinese company with $5.5 million training dollar budgets. And what they're referencing there is the fact that they were supposedly able to train this under $6 million. Engineers are moving frantically to dissect DeepSeek and copy anything and everything we can from it. I'm not even exaggerating. And this post from TechNode I thought was also interesting. Silicon Valley stunned as China's DeepSeek R1 surpasses US AI giants, undercuts costs. And if you were a Silicon Valley insider or a venture capitalist where you've pumped tens of millions, hundreds of millions of dollars into these new AI companies, of course you'd be freaked out because your entire business proposition may have just been completely undercut by a quote-unquote unknown Chinese company. Just looking at Andreessen Horowitz, their portfolio of AI companies is quite deep. For example, if we look at any scale, we can probably find their funding round on Crunchbase, and we can see that they've raised a total in their rounds. Let's go down to Series C, Series B, Series A. Let's just imagine for the Series A, led by Andreessen Horowitz. And it looks to have been about a $20 million Series A round. And across all of their rounds, it looks to be just above $250 million. Now, granted, it's not all apples to apples. It's not comparing apples and oranges. It's like trying to compare, maybe this is doing app development. Maybe they're doing mobile for AI. Maybe they're doing enterprise. Not every company that gets invested in is a foundation model company like OpenAI, Anthropic, or DeepSeek. But one of my biggest takeaways from all this is competition and disruption. Like, we're already seeing mass competition and disruption in the market, just from unknown players pumping out some very interesting models with very interesting techniques. And personally, I think that's very exciting. It's good for you and me using these things. Again, I think they're incredible tools. And I think that we'll continue to see new and better innovations and more powerful things to take advantage of. Like, I actually really enjoy using R1 for software development. It gives some really good answers and makes knowledge discovery that much better. So that's my hot take, at least on AI usage. But the competition, I think, will continue to be very, very interesting. So that's R1 and V3 and DeepSeek in a nutshell. There's lots of buzz going on around about it. Yes, maybe they did this on a handful of H800s. More likely than not, they have a bunch of H100s sitting around, like Alexander Wang mentioned. But the competition, again, is just very exciting to me. And I think for software engineers and people building day-to-day, it's exciting because there's more powerful tools out there to use. Please go with caution, because any of these foundation model companies that are running these platforms are going to use your data to train further. If that's a concern for you, then consider self-hosting a model on Ollama or on a small GPU cluster that you control the inference for and that you control the network for. So go with caution and be warned, but exciting times nonetheless. Thank you, everybody, for sticking around on this one. I will catch you on the next one. Peace, everybody.